Hello guys, welcome to Learn 360 Degree. Already we have covered the four parts of units and measurements, which is very useful topic for HSTR, GPSTR or even NCERT physics of class 11. So in units and measurement class 5, we are going to cover errors, and in previous classes we have already covered dimensional formula and significant figures with unnecessary examples. So in today's class, we will see errors and types of errors with example. So what is the meaning of error? Error is nothing but it is a lack in accuracy in the measurement due to limits of accuracy of an instrument or due to other cases. Means errors may occur because of an instrument or because of a person who is doing that experiment. So based upon that, we have a different types of errors, and these types of errors are absolute error, mean absolute error, relative error, and percentage error. So we will discuss these errors one by one with necessary useful examples. So first one is absolute error. What is the meaning of absolute error? The difference between true value. See here, one more word I am using here, mean value, and the measured value of a quantity is called as absolute error. So both true value or a mean value and measured value can be able to calculate at the time of experiment only. Means, let's take one example. If A1, A2, A3 so on up to AN, means if 5 observations are taken, then it will ends here at with A5. If you are taking 10 observations, then A10. Like that, nth observation is AN. Are the measured values. Just you have to remember the difference between the measured value and the true value. So whatever observations we have taken at the time of experiments are considered as measured values of any quantity A. Suppose we are measuring length, then first length L1, second length L2, third length L3 are so on up to nth observation when performed with n times. Then arithmetic mean of these values is called as true value or mean value. Just we have to perform the experiment at a given number of observation, then we have to take the mean values. Both can be calculated at the time of experiment only. So I will take one example for this. So before that, we will see the formula of absolute error. So absolute error is given by AM is equal to A1, A2, A3 plus so on up to AN up to nth observation divided by N, as we are going to calculate mean of this. So absolute error is measured in A1 is our first reading. So absolute error delta A1 is equal to AM. AM is nothing but our mean value and A1 is nothing but our measured value. Then absolute error for A2, delta A2 is equal to AM, again a mean observation, minus this will become A2, our second reading. Like that, absolute error for A3, delta A3 is equal to AM, again a mean observation, minus our third reading A3. Like this, so, delta AN is equal to mean observation delta AM minus delta AN. So, I will take a very useful example here. See, A1. Suppose we are going to measure a length of something. So, A1 measured as 10 centimeter, A2 measured as 11 centimeter, A3 measured as 9 centimeter. As this example showing a little bit more error, but I have taken this example to make it understand very clearly. If I took 9.1, 9.2, 9.3, it is very difficult to calculate a mean at the time of understanding. So you can try with another example. So we will first calculate the absolute error. Absolute error calculated by delta A1. But for that purpose, we require a mean value minus measured value. Means first we have to calculate the mean value of these three, then we can calculate delta A1, delta A2, delta A3, so on. So first I will calculate the mean of this. So mean of errors is equal to, we have a three errors, A1, A2, A3, and divided by n, means we have taken three measurements or three observations, hence divided by 3. So 10 plus 11 plus 9 divided by 3. So 10 plus 11 plus 9, it will become 30 divided by 3. So mean of this is 10 centimeter. So mean measurement or true value will become 10 centimeter. Then delta A1 is mean is 10 centimeter, minus measured is again 10 centimeter. So it is 0. Here in this case, absolute error is 0. Let's take for delta A2. Delta A2 again mean is 10 centimeter. Our A2 value is 11 centimeter. My answer is in now negative. So delta A3, our 10 centimeter minus A3 is 9 centimeter. Now I got a delta A3 as plus 1 centimeter. See here, we got absolute errors as 0, minus 1, plus 1. Means absolute error for first reading, second reading and third reading. Next we will go to mean absolute error. Again, this will also discuss with the help of previous example only. First, we will see the formula and meaning, then we will take a same example. The arithmetic mean of magnitude. See here, this word is very important because there we got a 0, plus 1 and minus 1 as errors. So hence we have to consider this magnitude words. It indicates what? If we got a minus term, that we have to consider plus 1 only. So magnitude of absolute errors in all the measurement is called as absolute error. Means if you are measuring length, it may be in meter. If you are measuring in weight, it may be in kg or it may be in gram with any unit. So delta A bar, it is denoted by delta A bar, mean absolute error. So mean of all those, mean of delta A1 plus delta A2 plus 3 on so on up to divided by n. I will discuss this with again same example. Here A1, A2, A3 we have previously taken 10, 11 and 9. There we got here delta A1 as 0, delta A2 as minus 1, delta A3 as plus 1. But if you take a mod of delta A1, again it is a 0. Mod of delta A2, it will become plus 1. Mod of delta A3, it is again a plus 1. So what our formula says, delta A bar mean absolute error. So delta A bar, so delta A bar is equal to mod of delta A1 plus mod of delta A2 plus mod of delta A3 divided by, as we have a 3 values, I will take it as divided by 3. If you have a 5 observation, then divided by 5. So 0 plus 1 divided by 3. Our mean absolute error is 2 by 3. If you want, you can write in terms of decimal also. So this is with example mean absolute error. Next, we have a relative error. This is a third type of error. In this relative error, the ratio of mean absolute error to true value is called as relative error. So already we have calculated mean absolute error and already we have calculated true value. So the ratio of these two will give relative error. So I will discuss this with the same example. Delta A1 got as 0, delta A2 as minus 1, delta A3 as plus 1. Mean absolute error. We got mean absolute error. Just check it out. What is mean absolute error? See here. Mean absolute error, we got it as 2 by 3. So I will take mean absolute error as 2 by 3 and true value or a mean error. In that case, we got in first case as 10 centimeter. So relative error is, say, see what definition says, mean absolute error divided by true value. Mean absolute error is 2 by 3 and true value is 10. So 2 by 3 into 10, which gives 2 by 30. Relative error is 2 by 30. Next, fourth type is percentage error. The relative error exposed in terms of percentage is called percentage error. So delta A bar divided by M into 100% means just uh, it is a case 3 where we have calculated already relative error 2 into divided by 30. So same example we will take delta A1 0, this is minus 1 plus 1, mean absolute error we got 2 by 3, relative error we got it as, see here, 2 by 30. So percentage of this, see just formula 2 by 30 into 100%. Percentage error 2 by 30 into 100%. That is nothing but this 0 and this 0 will cancel. This is 20 by 3%. You can, if you want, you can take in terms of decimal also. See here, already we have covered 4 errors. First one is, see, in this we have taken examples also. The first one is absolute error. Absolute error can be taken with, first we have to take a mean, then relative, absolute errors, delta A1, delta A2, A3 we can calculate. Then second example we have taken for mean absolute error. So mean of first case. Then third one is relative error. Mean absolute error divided by true value. True value is calculated in case 1. Mean absolute error is calculated in case 2. So with the help of formula, we can solve true value or a mean error. Then percentage error, just the percentage of case 3. Already we have covered these 4 types of errors. Then next point is propagation of error. Error in terms of addition or subtraction. Let x is calculated as a plus b. Means x is equal to a plus b, where a is one measured value and b is one measured value. Error may occurring at measuring a or measuring b. If a is having error, then x is also having error. If b is having error, even though b is having error, then x is also having error. Means x depends upon both a and b. If a and b are having their errors as delta a and delta b, then x is also with errors. X may be equal to a minus b. Both you can take in same case, means in addition or subtraction, same thing will happen. If measured values of two quantities are a and b, then a can be delta plus or minus a plus delta plus or minus a, and b plus or minus delta b. Means a is little bit more than a, what is exact measuring of a, or b is little bit more or less than exact value of b. Means if I take an example, if real value of a is 10 centimeter, then because of error, means error of point 1 plus or minus 1 can occur. Means if we are going to measure, then a1 becomes 10.1 centimeter, or while measuring second time it may become 9.9 centimeter. So based upon that, we have a delta a and delta b as little bit errors in measuring. Then maximum absolute error in their addition. Maximum error is taken as delta x is plus or minus delta a plus delta b. Means addition of errors is taken here. Then error in multiplication. Let x is equal to a into b or x is equal to a divided by b. If the measured values of a and b are, again it has a little bit more value or little bit less value based upon plus or minus. Again b is measured as plus or minus b plus delta b. Then maximum relative error in case of multiplication or division, it is taken as delta x by x plus or minus delta a by a plus delta b by b. This formula you have to remember for multiplication. See, for addition and subtraction, just it is an error of a and b. But for multiplication and division, you have to divide delta a by a plus delta b by b. Just you have to remember the formula with necessary examples. So, in today's class, we have covered errors, types of errors, and errors in addition and multiplication. And this is the last class of this series, units and measurement. So, thank you so much, guys, for watching this. If you liked this, please subscribe.